In today's lecture, I am going to teach you root mean square speed, that is RMS speed, and interpretation of temperature in kinetic theory. So first, root mean square speed. In last lecture, we have find out equation P is equal to 1 upon 3 n upon v m v square bar. So we have to find out root mean square, it is v square bar. So therefore v square bar is equal to 3 pm 3 pv. आपण v ला या साईडला घेतलं राहिलं 3 ला आपण घेतलं 3 pv divided by nm. Using ideal gas equation pv is equal to nRT. We have find it in our first lecture. Therefore v square bar is equal to 3 nRT divided by nm. We write nRT instead of PV. So therefore v square bar is equal to 3 nRT divided by Na upon nm. So n is equal to n upon Na, where n is the number of molecules and Na is the Avogadro number. So we put n upon Na instead of n. We put here n upon Na. So therefore v square bar is equal to 3 nRT divided by Na nm. So therefore square root of v square bar is equal to VRMS, that is VRMS root means square speed, that is V is equal to square root 3 RT divided by m naught, where m naught is the Na into m is the m naught, is the molar mass of the gas. Equation 3.12 allows us to estimate RMS speed of molecules of real gases. For nitrogen gas at 300 Kelvin, the RMS speed is 570 meter per second, while for oxygen gas it is 483 meter per second. You have studied passage of sound waves through air medium. Speed of sound in gas is Vs is equal to square root R gamma RT divided by m naught. आपल्या 11वीमध्ये साऊंड म्हणून एक लेसन आहे, त्याच्यामध्ये आपण स्पीडची व्हॅल्यू साऊंडचं स्पीड म्हणजे इथे व्ही एसने दाखवलं ते किती आहे साऊंडचं स्पीड, तर स्क्वेअर रूट गॅमा आर टी डिवाइडेड बाय एम नॉट, वेअर gamma is called adiabatic ratio, and which is the Cp upon Cv, that is constant specific heat at constant pressure specific heat divided by pressure specific heat at constant volume, that is adiabatic ratio. Its maximum value is 5 upon 3 for monoatomic gases. Now next we will going to see interpretation of temperature in kinetic theory. So using equation 3.10 can be written as PV is equal to 1 upon 3 n mv square bar, that is by using this equation. PV is equal to 1 upon 3 nmv square bar. So there is equal to, we multiply and divide by 2. So therefore 2 upon 3 n 1 upon 2 mv square bar. So it gives the kinetic energy, linear or translational kinetic energy of a molecule. So in an ideal gas, the molecules are non interacting and hence there is no potential energy term. Thus the internal energy of an ideal gas is purely kinetic. The average total energy E therefore is E is equal to n 1 upon 2 mv square bar. So it gives the total energy of the gas, that is E is equal to n 1 upon 2 mv square bar. So using this equation, PV is equal to 2 upon 3. This is a 2 upon 3 and here is a E. So 2 upon 3 E. Therefore PV is equal to 2 upon 3 E. Using ideal gas equation, PV is equal to n kBT. हे पण इक्वेशन आपण फर्स्ट लेक्चरला काढलं होतं, where kb is called a Boltzmann constant, n is the number of molecules, t is the temperature. So therefore PV is equal to n kb t is equal to 2 upon 3 E, that is PV is equal to 2 upon 3 E. So therefore PV is equal to 2 upon 3 E. So therefore E is equal to 3 upon 2 n kBT. This E is equal to 3 upon 3 ला आपण या साईडला आणलं 3 upon 2 n kBT or E upon n this n. E upon n is equal to 3 upon 2 kBT. This means that the average energy per molecule is proportional to, that is E upon n. E upon n is average energy per molecule is proportional to temperature T of the gas. This equation relates the macroscopic parameters of the gas T to the kinetic energy of a molecule. Thank you.